Before human industry, species died off at a slow, measurable pace, known as the background extinction rate. This dial represents that historical baseline, between 1 and 5 species lost per year. Today, that rate has multiplied by a factor of 1,000. This acceleration is explicitly linked to us. Human activity is the direct cause of risk for 99% of all currently threatened species. This data tree maps known life, starting with the 1.9 million species described by science. Out of that total, researchers have assessed a fraction, just over 41,000. Within that group, over 16,000 are actively threatened. We are watching an anthropogenic culling of life. Halting this requires shifting from simple head counts to a diagnostic analysis of the specific mechanisms of death. The IUCN Red List is the world's most comprehensive inventory of the global conservation status of biological diversity. The data here shows that habitat loss and degradation are universal pressures, affecting between 86 and 88% of all threatened birds, mammals, and amphibians. But attributing a population collapse solely to habitat loss lacks the scientific granularity required to actually stop it. Beyond the bulldozing of forests, species are being targeted by acute threat factors, specific, highly dynamic mechanisms that exploit distinct biological vulnerabilities. The Red List functions as an epidemiological tool. It allows researchers to pinpoint the exact pathogens, industrial poisons, and ecological processes driving rapid population collapses. Consider amphibians, a biological class facing disproportionate ecological pressure. The executive summary records the severity of their decline. Nearly 1 in 3 amphibian species is currently threatened with extinction. The primary biological driver here is chytridiomycosis, a highly infectious fungal disease. Under a microscope, these fungal spores rapidly multiply, forming a dense network across the animal's porous skin, effectively suffocating it and causing cardiac arrest. However, the disease requires an environmental catalyst to reach mass lethality, specifically extreme climatic events like prolonged droughts. This diagram illustrates the interaction. As global temperatures shift and alter moisture levels, the frogs are stressed and the fungus thrives, creating a devastating feedback loop. The rapid decline of amphibians demonstrates that extinction is rarely driven by a single variable. It is a deadly synergy between massive environmental shifts and microscopic pathogens. Our closest evolutionary relatives, the great apes, are facing a similarly complex threat matrix. Recent assessments have forced the classification of the western gorilla from endangered down to critically endangered. The initial cause of this downgrade points to aggressive human predation through the commercial bushmeat trade. But the data reveals a secondary, hidden threat vector operating independently of poachers, the Ebola virus. The combined impact of poaching and disease has driven the population down by more than 60% in just the last 25 years. Ebola has bypassed human countermeasures entirely, killing roughly 1/3 of the gorilla population located strictly within protected nature reserves over the last 15 years. Static geographic borders and armed park rangers offer no protection against highly mobile, cross-species epidemiological threats. This diagnostic complexity extends to avian scavengers. Over just 8 years, Old World vultures across both Asia and Africa have suffered catastrophic population collapses. In Asia, the vector traces back to a specific livestock pharmaceutical called diclofenac. This flowchart tracks the toxicological transfer. An anti-inflammatory drug meant to treat cattle becomes highly toxic when those carcasses are consumed by scavenging birds, leading to widespread renal failure. Yet in Africa, the exact same class of bird is collapsing for entirely different reasons. The first African vector is agricultural conflict. Farmers lace carcasses with insecticide to kill predators like hyenas, inadvertently poisoning the vultures that arrive to feed. The second vector is infrastructure. As human development expands, these birds are colliding with newly constructed electrical power lines. Global ecological niches are collapsing simultaneously through a fragmented array of localized industrial byproducts, each unique to its own continental landscape. Pulling back from specific species, the aggregate data reveals a massive shift in where extinctions are actually occurring. Since 1500 AD, The historical record shows that the vast majority of documented extinctions occurred within the fragile, closed ecosystems of isolated oceanic islands. Over the last 20 years, that geography has changed. Roughly 50% of recent extinctions have occurred on major continents. The new front lines of this crisis are now localized in Central and South America, Sub-Saharan Africa, and Southeast Asia. These landmasses contain the tropical and subtropical moist broadleaf forests, the deep continental environments believed to host the vast majority of Earth's terrestrial and freshwater species. The crisis has breached the planet's most ancient and robust ecosystems. To combat this, researchers use Red List indices, analytical models that track changes in extinction risk over time, to measure both ongoing decline and the success of mitigation efforts. The Mauritius echo parakeet provides a proven model for targeted mitigation. Once one of the rarest parrots on Earth, rigorous data tracking over the last 15 years confirms its status has improved from critically endangered to endangered. This recovery required exact, hyper-specific interventions, close monitoring of nesting sites, supplementary feeding programs, and captive breeding. These actions succeeded specifically because conservationists had exact diagnostic data identifying precisely why the birds were dying. Defeating the extinction crisis requires this level of clinical precision. Pinpointing the exact biological or industrial mechanism of a population's collapse is the only proven way to engineer its survival.